What's up everyone, this is going to be a quick video describing this Arduino project kit, which comes with a variety of sensors and a microcontroller, and this will be a brief introduction of how to get started, how to connect it to your computer, and how to connect several of these wires and sensors to the breadboard in order to create several circuits. The first lesson is about the libraries and the IDE. So once your zip file is downloaded from the Arduino website, in order to add libraries, you go to Sketch, and then you go to Include Library, Manage Libraries, and then a whole list will pop up. And these libraries pretty much are dedicated to a certain sensor, so depending what sensor you're using, you could install libraries from this library manager. You could also install libraries as a zip file, doing the same thing: Sketch, Include Library, and instead of Show Manage Libraries, you put Add a Zip Library, and you add from the file that you saved on your computer. This lesson also includes how to connect your microcontroller to your computer. So your microcontroller, it comes also with a serial port and USB cable, which is this blue cable. So in order to connect it, you plug in the serial port into the microcontroller, and once it's all plugged in, your computer will recognize it, and you can connect with this top right button with the magnifying glass, which is serial monitor. You know your device is connected when it will start blinking. After several seconds, you can press the serial monitor. You can then check if your device is connected by going to Tools, and in the port section, it should be this Arduino that pops up. And once your device is connected, you're ready to input code, the setup and the loop sections, and test out the different programs that you create. The lesson 2 is the Blink project, which makes the built-in LED, which is this yellow light right here, flash. So what this code does is that it can create the LED to flash faster based on these times are right here, the delay times. So how this code works is it first sets the built-in LED, which is at pin 13, set as an output, and then one writes a high value onto the LED, which makes it on, and then an off value. So based on the delay time, it'll turn on and off, and if the delay time is shorter, it'll go on and off faster, and these times are in milliseconds. So if I change the values to 500, the LED should light faster. And in order to upload the code onto the microcontroller, you go to this right arrow right here, upload. And this is the result of the LED. Lesson 3 is about how to shine an LED using resistors. So resistors have a certain resistance value based on the stripes that are on the resistors, and this is the code. So based on the colors on the stripe, it's a different resistance value. So what a resistor does, it reduces the flow of electricity. So therefore, the less resistance you have, the brighter the LED will be. So in this circuit, we have the microcontroller, which is providing 5 volts on this red wire, and this black wire is connected to ground. And we have the LED along with the resistor. The resistor is 220 ohms. If you do not have the resistor, the LED will blow up, so it is essential to the circuit, and that's pretty much it. Lesson 4 is the RGB LED project. So this is the setup of the project. The microcontroller, 3 wires connected from the digital side onto the breadboard with 3 220 ohm resistors, and the light changes from blue to red, and then to green. So how this works is that you initially set the code to start at a maximum red value of 255 and set green and blue at 0. Then you create a for loop which iterates the code 255 times, which lessens the red value by 1 and increases the green value. Therefore, the red will decrease and the green will increase, making the LED look green. Then the same happens between the green and the blue value in this for loop, as the green value is decreased by 1 and the blue value increases by 1. After that, then the iterations go between the blue value and the red value, and this iteration keeps on going, which makes the light switch from blue to red and then to green, and then keep on continuing after that. Project 5 is with digital inputs. So what this code initializes with is the setup. So it sets up the LED pin as number 5, button A as 9, and button B as 8. And this is how it looks on the microcontroller. So you have several wires connected to 5, 9, and 8, connected to certain rows on the breadboard. And I have button A and button B located right here. And the purpose of this code is as I press button A, the light should turn on, and once I press button B, the light should turn off. And how this code does it is whenever it sets up the pins right here, this input pull-up means that if button A is low, then that means the sensor is on. So this if statement says it reads, I guess, the value at button A. So if it's low, if it's pressed, then LED pin high, turn on the LED. And it's the same for button B. If it's pressed, then turn off the LED. And that's what makes the LED turn on and off as you switch through the buttons. Project 6 has a buzzer working. So what it does is it uses a for loop, and a buzzer has the high and the low depending the different types of frequencies. So it plays the higher frequency and also a lower frequency, and then it gives a delay of 1 millisecond, so it oscillates from the high to the low frequency up and down. So in the beginning it initializes at pin 12, and this is what the connection looks like. So once I connect this red cable into pin 12, the buzzers just start making noise. Lesson 7 is similar to lesson 6, yet in this one we use a passive buzzer. So the only difference between a passive buzzer is that it can play different notes. So C, D, E, F, G, A, B, and C. So this for loop iterates through each note, and each note is played for a certain duration of time. And then after that, the notes start to replay. The scale goes from low frequency to high frequency, and it restarts every 2 seconds. So this is what the program looks like. Lesson 8 introduces this tilt switch, which is this device right here, and it's connected to ground and a port on the microcontroller. So what the device does is it acts as a switch, but it's some sort of rotational switch. So there's like a free mass inside, and as you tilt it on one side, the mass goes to one pole, and if you tilt it in the other, it goes to another pole. And pretty much, depending on what pole the mass is on, it'll act differently in the code, as you can add certain statements depending on what side of the pole the free mass is on. So initially, we're going to be using the LED attached to the microcontroller, which is LED pin 13. So we set up all the pins, and then it reads So this reads the value of the device, and if it's high, then you turn the LED off. If it's not, if it's on the other side of the pole, then you turn it on. So how this works, this LED should turn on if I have it inclined to the right pole, and as I tilt it, it turns off. On, off. The servo motor, and what a servo motor does is it rotates from 0 to 180 degrees, and this is the result from project 8. So all I connected was the certain wires to the designated ports. So the red wire goes to the 5 volt on the power side of the microcontroller. The black wire goes to ground, and the orange wire is the designated port that you set the microcontroller at. And in this case, in the code, it is set as port 9. So then after that, it uses a loop to switch the position from 0 to 180 in the first for loop, and then after a delay of 15 milliseconds, it switches the direction from 180 to 0. So that's what makes it oscillate from 0 to 180 back and forth. Lesson 10 requires the ultrasonic sensor, which is this sensor right here. So what it does is it sets the ultrasonic sensor, defines them as 12 and 11, and it also uses a specific library for the ultrasonic sensors. So if you don't have that, you would have to download it again from, similar to lesson 1 from the library manager. So what it states is some sort of distance A. It creates a variable, and the serial begins the ultrasonic sensor in order to start capturing data, and the data is saved onto this variable called A, and then it is printed on the monitor screen in units of centimeters, and it repeats this every 1000 milliseconds. So what this looks like is, if you open up the serial monitor, it will display certain distances from the closest. So right now it's at 58, and if I move it a little bit back, it increases to 62, as it is trying to capture the distance from here to the wall. Project 11 is working with a temperature and humidity sensor, which looks like this. The device itself has 4 pins, yet it only has three pins that can connect to the microcontroller. Therefore, it has a ground, a signal pin, and also a voltage pin. So the voltage pin is connected to the 5 volts, the ground to the ground on the analog side, and then the signal side is connected to digital pin 2. So this is the code. It initially starts the temperature and humidity at 0, and it reads the DHT11. This is the name of the sensor, and it reads for temperature and humidity. And then serial print, it prints it out in the serial monitor. So once we open up the serial monitor, we should see data that correlates to the temperature and humidity, which is these right here.